Hello at magandang gabi po sa inyong lahat. Gusto niyo ba hong malaman tungkol sa mga outer planets ng ating solar system? Gusto niyo ba hong malaman tungkol sa mga planetang Jupiter, Saturn, Uranus at Neptune? At isama na rin po natin ang dwarf planet na Pluto. So please watch this third episode of Space, the Final Frontier. Okay po, wag po kayong bibitiw and watch this episode.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone.
There she is. NASA's Voyager 1. Launched in 1977.
But that's just very small potatoes compared to what the Earth is involved with and knows about.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
One small step for man, one giant leap for mankind.
Hello, good evening, and welcome to our third episode of Space, the Final Frontier. I am Professor Cajigal. Now, Space, the Final Frontier is a series of online lectures intended to help our students out there in their schooling or online classes. Ito po ay aming munting handog sa mga estudyante para makatulong po kami sa kanilang pag-aaral, lalong-lalo na po sa siyensya. And for tonight's episode, episode 3, we will be focusing on the outer planets of the solar system. Okay, so sana po matapos niyo po itong video na ito para marami po kayong matutunan about the outer planets of the solar system. And pag may mga katanungan po kayo, if you have any questions later, please feel free to comment down. Okay, at aming sasagutin ang inyong mga katanungan, and wag po kayong mahiya, and we are glad and we are happy to answer all your comments and all your questions. And also, please subscribe and click on the notification bell para ma-update po kayo sa aming mga future videos. Okay, so let's not waste any more time. So I will now be giving you a guided tour of the outer planets of the solar system through this third episode of Space, the Final Frontier. Hello, greetings, and welcome to this live stream event entitled A Tour of the Solar System. I am Professor Cajigal from the Vedan Society of Young Astronomers, and I will be giving you a guided tour of our solar system. So for tonight, we will be visiting the outer planets of the solar system. So come with me and let us now beam to our Starship Enterprise, and let us now go where no man has gone before. So let us now travel at warp speed to the outer planets of the solar system. But before we can reach our first destination, which is the mighty Jupiter, we will have to cross first the asteroid belt. Now, the asteroid belt is that region between the orbits of Mars and Jupiter. And this region is composed of small to large irregularly shaped objects called asteroids. Okay, and again, these asteroids are located between Mars and Jupiter. So you will notice that there is a huge gap between Mars and Jupiter, and this huge gap is occupied by those asteroids or those irregularly shaped objects. Okay, so let us now place our starship at impulse power. Let's slow down a bit, and let us now cross the asteroid belt. And at the same time, let's activate our sensors so that we can gather information about the asteroids and the asteroid belt. Now, what are asteroids? Now, asteroids, these are small, irregular shaped objects, mostly in the apparent gap between the orbits of Mars and Jupiter. Now, there are thousands of these asteroids located in that gap between Mars and Jupiter. Now, many astronomers believed that asteroids are actually remnants of a planet that broke up some 4.6 billion years ago. So there was a planet in that region between Mars and Jupiter, and for some unknown cause, that planet broke up, and the remains now are the asteroids that we see today. Okay, so here is a picture of some asteroids that orbit the Sun between Mars and Jupiter. So we have the following like Matilde, Gaspra, Eros, Itokawa, and we may include also Phobos and Deimos. Though Phobos and Deimos are Martian moons, many astronomers believe that Phobos and Deimos may have been captured asteroids from the asteroid belt. Okay, so those are the asteroids located in that region between Mars and Jupiter. Now, there are several space probes that have visited the asteroids and the asteroid belt. So they include the following, such as NASA's Galileo mission was the first spacecraft to fly past an asteroid. It flew past the asteroid Gaspara in 1991 and the asteroid Ida in 1993. Then we have NASA's Near-Earth Asteroid Rendezvous or NEAR Shoemaker, studied the asteroids Matilde and Eros, and the Rosetta mission encountered Steins in 2008 and Lutitia in 2010. Then we have in 2005 the Japanese spacecraft Hayabusa landed on the near-Earth asteroid Itokawa and attempted to collect samples. Then on June 3 of 2010, Hayabusa successfully returned to Earth, a small amount of asteroid dust now being studied by scientists. And lastly, we have the NASA's Dawn spacecraft. The Dawn spacecraft was launched in 2007 and orbited and explored the asteroid Vesta for over a year. Alright, so this is the Near Shoemaker space probe, and this is Hayabusa that visited the asteroid Itokawa. Okay, so I guess we can now go back to our Starship Enterprise and let us now travel at warp speed on our way to our next stop on our journey to the solar system. So we shall now visit the mighty Jupiter. Now that's a symbol for Jupiter. The planet was named after the Roman supreme god. The Greek counterpart of Jupiter is Zeus. Okay, so let us now activate our sensors and let us now gather information about the mighty Jupiter. Now, in terms of mass, Jupiter has a mass that is 2.5 times greater than the mass of all the other planets, including their moons combined. That's how massive Jupiter is. The mass of Jupiter is 2.5 times greater than the mass of all the other planets and their moons combined. Okay? Alright, so let us compare now Jupiter with the Earth in terms of its size. So this blue dot is our planet and this is the mighty Jupiter. Okay, that's why Jupiter is the largest planet in our solar system. Okay, let's talk about now the atmosphere of Jupiter. Now, the atmosphere of Jupiter is composed of the following. So, the atmosphere is composed mostly of hydrogen and helium with traces of methane and ammonia. Okay? Alright, let's take a look at this pie chart showing the composition of the atmosphere of Jupiter. So, the atmosphere of Jupiter is composed mostly of hydrogen at around 89.8%. And you have 10.2% helium. Plus, you have the other gases such as methane and ammonia. Alright, so that's the composition of the atmosphere of Jupiter. Now, there are certain odd features in the atmosphere of Jupiter. Now, one such example is the so-called Great Red Spot. This great red spot has been observed by many astronomers, including Galileo Galilei. Now, when the Voyager space probe visited Jupiter, they found out that this great red spot is actually a giant storm. Alright, so that's the great red spot, and astronomers have discovered that this great red spot is actually a giant cyclonic storm that has been raging the atmosphere of Jupiter. The great red spot is even larger than planet Earth, about 3 times that of the size of planet Earth. Alright, so that's the great red spot, which is a giant storm. Alright, so fantastic, isn't it? Now, if you will look closely at the great red spot, you will notice that the great red spot is rotating in a counterclockwise direction, just like any storm here on Earth. Okay? So that's the great red spot, which is actually a giant cyclonic storm. Okay? Alright, so that's the great red spot of the mighty Jupiter. And you will notice that the atmosphere of Jupiter has a banded or belted appearance. And look at the bands or belts of the atmosphere of Jupiter. The bands or belts are moving in opposite directions. So isn't that fascinating? So the atmosphere of Jupiter has a banded or belted appearance, and these belts or bands are moving in opposite directions. Right? And we have here the famous North Equatorial Belt or the North Equatorial Band, and the South Equatorial Belt or the South Equatorial Band. So those belts, the North and South Equatorial belts, can be seen even through the telescopes of amateur astronomers. Alright, so those are the belts in the atmosphere of Jupiter. Now, these belts or bands, they are so magnificent when seen through the telescopes of amateur astronomers. Okay, so again, here are the bands or belts in the atmosphere of Jupiter, and again, they move in opposite directions. And we have here the famous great red spot of Jupiter, which is really a cyclonic storm. Okay, so what about now the rotation of Jupiter on its axis? Now, Jupiter is considered the most rapidly rotating planet in the solar system. Its rotation period is slightly less than 10 hours, or about 9 hours and 50 minutes to be exact. That's the rotation period of Jupiter. Jupiter rotates in just 9 hours and 50 minutes at the equator. Now, because of this rapid rotation on its axis, the shape of Jupiter is not really that of a perfect sphere, but the shape of Jupiter is somewhat bulging at the equator and slightly flattened at the poles. So we call this an oblate spheroid. Okay, so that's the shape of Jupiter because of its rapid rotation. And because of this unusual shape of Jupiter, it means only one thing, that Jupiter has a non-solid surface or a non-solid structure. Okay, so Jupiter is made up of gas. Okay, Jupiter is a gas planet. Now, even though Jupiter is a gas planet, Jupiter was not spared from comets and asteroid bombardments. So one example was the collision of Shoemaker-Levy 9 to Jupiter. Alright, so that encircled part of Jupiter was Shoemaker-Levy 9, which is a comet. This comet collided with the mighty Jupiter. So even the gas planets were not spared from asteroids or comet bombardments. So even the inner planets were not spared, like Mercury. So an asteroid bombarded Mercury that created the Caloris Basin. Alright, Venus was not spared. So a protoplanet or a huge asteroid bombarded Venus, and because of that, the rotation of Venus was shifted from counterclockwise to clockwise. Okay, Earth was not spared also. And there was this asteroid that bombarded the Earth 65 million years ago that wiped out 95% of life on Earth, including the dinosaurs. Right? Mars was not even spared. So there was an asteroid that bombarded Mars that created Hellas Planitia. Right? Jupiter collided with a comet just recently, the so-called Shoemaker-Levy 9. Now, because of the intense gravitational field of Jupiter, many astronomers believe that actually Jupiter protects us from these asteroids and comet bombardments. Now, due to the gravitational field of the mighty Jupiter, Jupiter actually deflects the direction of comets or asteroids that might hit our planet. So let us thank the mighty Jupiter for protecting us from potential asteroids or comet bombardments. Now that's really fascinating about how Jupiter protected us from potential asteroid and comet bombardments. Okay, so let us now study the so-called Galilean moons. Now, these Galilean moons, these are the 4 largest moons of Jupiter as discovered by Galileo Galilei. Now, remember, Jupiter is orbited by more than 64 moons, but these are the 4 largest moons of Jupiter as discovered by Galileo Galilei. So let us now direct our starship and let us now visit those 4 largest moons of Jupiter. And let us now activate our sensors so that we can gather information about those 4 moons of Jupiter. Okay, so these are the 4 largest moons of Jupiter. So we have Io, Europa, Ganymede, and Callisto. So these are the 4 largest moons of Jupiter as discovered by Galileo. So they are the so-called Galilean moons. But again, remember, Jupiter is orbited by more than 64 plus moons. Okay? So these are the 4 largest moons of Jupiter. We have Io, Europa, Ganymede, and Callisto. Alright? So let us now start with Europa. Now, Europa is made up primarily of silicate rock. And what is surprising about Europa is that the surface of Europa is composed of ice that is solid water. And that makes Europa one of the smoothest of the moons in the solar system. The surface of Europa is also striated as seen by Voyager. It is striated by cracks and streaks. This is due to the tidal forces between Europa and Jupiter. Okay, that's why the surface of Europa is striated with cracks and streaks. And this is again due to the tidal forces between Europa and the mighty Jupiter. And again, the surface of Europa is covered with ice. And you know what that means. So ice is solid water, and we know that beneath that solid icy sheet, there is liquid water beneath that icy solid sheet of Europa. And because of that, Europa is a prime candidate for the existence of life beyond planet Earth. In astrobiology, the search for life outside Earth is the search for water. And that's really fascinating about Europa. So beneath that icy covering, there is liquid water under that icy sheet. That makes Europa a good candidate for the existence of life. Again, in astrobiology, the search for life outside planet Earth is the search for water. And NASA is planning to send a space probe on Europa. This space probe will drill a hole through that solid icy sheet of Europa, and once it penetrated that icy sheet, it will send a robotic submarine to explore that liquid ocean underneath that icy sheet of Europa. Now that is really fascinating about Europa. Okay, our next stop now is Callisto. Now, Callisto is composed of equal amounts of rock and ice. And what is unusual about Callisto is that Callisto is a heavily cratered moon of Jupiter. Now look closely at this photo taken by the Voyager space probe. And again, you will see that the surface of Callisto is really heavily cratered. Okay? Alright, our next stop now is Io. Now, Io is so unusual because Io has more than 400 active volcanoes on its surface. Io is considered one of the most geologically active objects in the solar system with more than 400 active volcanoes. Okay? And as discovered by Voyager, there are plumes of sulfur dioxide, okay, erupting from those volcanoes on the surface of Io, as you could see in this photo taken by the Voyager space probe. So Io really is geologically active with plumes of sulfur dioxide emanating from its surface. Okay? And the surface of Io is yellow, again because of sulfur dioxide. Alright? Okay, so that's quite fascinating, isn't it? Okay, so these are the plumes of sulfur dioxide erupting from those volcanoes on the surface of Io. Okay, so Io is considered one of the most geologically active objects in the solar system. Okay, and lastly we have Ganymede. Okay, now Ganymede, just like Callisto, is also heavily cratered, and Ganymede is composed of equal amounts of rock and ice, just like Callisto. Okay, so as you could see that the surface of Ganymede is heavily cratered. And what is unusual about Ganymede is that Ganymede is the largest moon, not only in Jupiter, but the largest moon in the solar system. So look at this picture taken by Voyager, that the surface of Ganymede is heavily cratered just like Callisto. Now that's Ganymede, the largest moon in the solar system. Okay, so at this point, let us now study the exploration of Jupiter. Now, Jupiter has been visited by Pioneer 10. Pioneer 10 is an American space probe launched in 1972 and completed the first mission to the planet Jupiter. And Pioneer 10 also became the first to achieve the escape velocity needed to leave the solar system. So after its flyby mission to Jupiter, Pioneer 10 left the solar system. Okay, now what is so special about Pioneer 10? Now inside Pioneer 10 is a golden plaque. So something like this, and this plaque was designed by no other than Carl Sagan. Now, this plaque contains the following information. So we have here the images of man and woman. And right down here, we have here the solar system. And this is a sketch of Pioneer 10. And it shows where Pioneer 10 originated right here in this third rock in the solar system. So this represents planet Earth. Okay, and this is a representation of the hydrogen and helium atoms. And we have here a simple sketch of the Pioneer 10 space probe. So come to think of it, Pioneer 10 is like a message in a bottle. So since it is out in the solar system, who knows, someday intelligent alien life forms may pick up Pioneer 10 and hopefully they can decipher this golden plaque so that they would know who we are. Now, 6 years after the success of Pioneer 10, NASA launched Voyager. There were 2 Voyager missions, Voyager 1 and Voyager 2. The Voyager missions vastly improved our understanding of the Galilean moons. The Voyager missions was able to take high-resolution images of the planet Jupiter, and the Voyager missions have discovered the rings of Jupiter. So we know now that Jupiter is surrounded by rings. The rings of Jupiter are made of rocky material, probably from the asteroid belt, in contrast to the rings of Saturn, which is made of ice. And the Voyager missions also discovered that the Great Red Spot is actually a giant cyclonic storm. Now that's really fascinating about Voyager. Now there were 2 Voyager missions sent by NASA, Voyager 1 and Voyager 2. Now Voyager 1 went on a flyby mission to Jupiter and Saturn. Now, after visiting Saturn, Voyager 1 went out of the solar system and is now on its journey into interstellar space. While Voyager 2 continued in its grand tour of the outer planets of the solar system, visiting Saturn, Uranus, and Neptune before leaving the solar system and into interstellar space. Now, what is so unique about the Voyager spacecraft? Now, inside the Voyager spacecraft is a golden record. Now, recorded or stored in that golden record are the images and music of our planet. So that golden record is like a message in a bottle, like Pioneer 10. So we are hoping that some intelligent life may pick up both Voyager spacecraft, Voyager 1 and 2. And hopefully they may decipher the hidden message that is stored in those golden records stored in Voyager 1 and 2. Okay? So we are looking forward that someday that some alien civilization may pick up our message in a bottle. That's Voyagers 1 and 2. Now, isn't that fascinating about Voyager? Okay, so both Voyagers 1 and 2 are now out of the solar system and they are now on their journey to interstellar space with the golden records, hoping that someday some alien life forms may pick up Voyager 1 and 2. Okay, so Voyager is now out in interstellar space where no man has ever gone before. Okay, so I guess that's it for Jupiter. So let us now beam back to our starship and let us now travel at warp speed on our way to the next stop in our journey to the solar system. So we shall now visit the planet Saturn. So that's the symbol for Saturn. Saturn was named after the Roman god of agriculture. So let us place now our starship in parking orbit around Saturn. And let us now activate our sensors so that we can gather data about this magnificent ringed planet. Now, Saturn revolves around the Sun at an average distance of about 1.4 billion kilometers. The atmosphere of Saturn is very similar to Jupiter, with hydrogen and helium as the most abundant gases, with traces of methane and ammonia. And in terms of the density of the planet, Saturn has the lowest density of any planet in the solar system. In fact, if you will allow Saturn to float on a gargantuan sea, Saturn will really float because of its very low density. Now, let's compare the size of Saturn with that of planet Earth. Now, looking at this photo, it is quite obvious that Saturn is the second largest planet in the solar system. Okay, but in spite of its size, Saturn has the lowest density of all the planets in the solar system. Now, in terms of its rotation on its axis and its revolution around the Sun, Saturn has the second shortest day in the solar system. So one day on Saturn takes only about 10.7 hours. Jupiter is still the fastest. Then second is Saturn. So one day in Saturn is only 10 hours and 7 minutes. Okay? And in terms of its revolution around the Sun, Saturn makes a complete orbit around the Sun in about 29.4 Earth years. Okay, so that's the rotation of Saturn on its axis and its revolution around the Sun. Now, going back to the atmosphere of Saturn, the atmosphere of Saturn exhibits a banded or belted appearance which is similar to Jupiter. But the atmospheric belts or atmospheric bands of Saturn are much fainter and wider near the equator. And the atmosphere of Saturn is quite violent and active with high-speed winds of about 1,500 kilometers per hour. So isn't that fascinating about the atmosphere of Saturn? Okay, so what about the rings of Saturn? Now, the rings of Saturn are made of particles of ice, ranging in size from a grain of sand to the size of an automobile. And since the rings are made of ice, the rings of Saturn is highly reflective in contrast to the rings of Jupiter, which is made up of rocky material. Okay? And many astronomers believed that the rings of Saturn are the remnants of a destroyed moon of Saturn. Okay, so you can just imagine if our own moon explodes or if our own moon is destroyed, then the remnants of our own moon would encircle the Earth, forming rings. So just like Saturn, so many astronomers believe that the rings of Saturn are the remnants of a destroyed moon of Saturn. And the rings of Saturn again are made up of ice particles ranging from grains of sand to the size of automobiles. So these ice particles, they are like tiny moons orbiting Saturn. Okay? And there are times that the rings of Saturn is tilted or angled as seen to Earth-based telescopes. As you could see in this animated illustration, that year after year from 2012 to 2015, the planet, including the rings, gets tilted. And that's really amazing. This is seen by amateur astronomers using their Earth-based telescopes. Okay. Now, Giovanni Cassini, if you will recall, Giovanni Cassini discovered a huge gap between the A ring and the B ring of Saturn. This huge gap is known as the Cassini division, named after him. So the Cassini division is that gap between the A ring and the B ring of Saturn. Okay, so that's the Cassini division. This is seen easily even through Earth-based telescopes. Okay, so that's the rings of Saturn and the Cassini division. Alright, let's talk about now the moons of Saturn. Now, Saturn is orbited by many moons just like Jupiter. The largest moon of Saturn is Titan. Okay, so that's Titan, and Titan is the only moon in the solar system that has a dense atmosphere. Okay, Titan is the largest moon of Saturn, and Titan is the only moon in the solar system that has a dense atmosphere. And you will be surprised that the atmosphere of Titan is composed mostly of nitrogen, which is similar to Earth. The Earth's atmosphere is composed mostly of nitrogen, about 71%, and 21% oxygen. The atmosphere of Titan is composed mainly of nitrogen. So Titan is a candidate for the existence of life outside planet Earth. Now, let's compare Titan with that of our moon in terms of size. Now, it's obvious that Titan is much bigger than our own moon, and Titan is still much bigger than Triton. Triton is the largest moon of Neptune. So Titan is the only moon in the solar system that has a dense atmosphere composed mostly of nitrogen, very similar to Earth. And Titan has been visited by the Huygens space probe. The Huygens space probe successfully landed on Titan, and the Huygens probe discovered lakes of methane. So that makes Titan a pretty good candidate for the existence of life, because maybe on those methane lakes, extremophiles, specifically methanogens, may exist. Just like here on Earth. Here on Earth, we have microorganisms called methanogens that can tolerate high concentrations of methane. So most probably, if we would send another mission to Titan, hopefully we can discover those extremophiles or microorganisms that can tolerate high concentrations of methane. Okay, now what about the exploration of Saturn? Now, Saturn has been visited by Pioneer 11. Pioneer 11 carried out the first flyby mission to Saturn in September of 1979. Then it passed within 20,000 kilometers of the planet's cloud tops, and images were taken of the planet and few of its moons. So that's Pioneer 11. Then in November of 1980, Saturn was visited by Voyager 1. Voyager 1 took high-resolution images of Saturn, its rings, and its satellites. And after that flyby mission, Voyager 1 went out of the solar system, and it is now in interstellar space. Okay? Then Saturn has been visited in July of 2004 by the Cassini-Huygens space probe. The Cassini-Huygens space probe performed the SOI, or Saturn Orbit Insertion. So the spacecraft entered into orbit around Saturn. Okay, so this is the Cassini-Huygens probe The Cassini-Huygens mission is actually made up of two spacecraft. So we have the Cassini and the Huygens probe. The Huygens probe landed on Titan. Okay, so that's the Cassini-Huygens space probe. Alright, so I guess that's about it for our visit to Saturn. So let us go back to our starship and let us now move to our next stop in our journey through the solar system. Our next stop is the planet Uranus. Now let's activate our sensors and let us now gather information about this mysterious planet Uranus. Now Uranus was the first planet to be discovered using a telescope. And in 1781, an amateur astronomer by the name of William Herschel discovered a planet beyond Saturn in 1781 using the parallax method and using the newly invented telescope. So William Herschel by chance discovered Uranus in 1781. And Uranus revolves around the Sun once every 84 years. Its average distance from the Sun is roughly 3 billion kilometers. So talagang malayo po ang Uranus. And what is so unusual about Uranus is that the rotational period of the interior of Uranus is 17 hours and 14 minutes. And it's unusual because its rotation is clockwise or retrograde, which is similar to Venus. So Uranus exhibits a retrograde rotation on its axis, which is similar to Venus. Now, one reason why Uranus exhibits a retrograde rotation on its axis, it's because during the early history of Uranus, Uranus encountered a collision with a massive protoplanet. And this protoplanet, when it collided with Uranus, it shifted the direction of its rotation from counterclockwise to clockwise. So if you will notice, what happened to Uranus was also similar to Venus. Venus also encountered a massive collision with the protoplanet that shifted its rotation from counterclockwise to clockwise. Uranus also encountered a similar fate. Okay, so that's what happened during the early history of Uranus. Now, let's compare the size of Uranus with that of planet Earth. Now, it's obvious in this picture that Uranus is much bigger than planet Earth. In fact, 63 Earths will fit into Uranus, and that's how big the planet is. And this is the reason why we should pronounce it as Uranus and not Uranus. Because kung babasahin po natin yung statement, 63 Earths will fit into Uranus. So parang ang pangit po pakinggan. 63 Earths will fit into Uranus and 64 if you relax. Diba? Parang bakit pakinggan sa tenga? 63 Earths will fit into Uranus. So we should pronounce it as Uranus. Yan, para social. And not Uranus. Okay? Alright, so pinapatawa ko lang po kayo. Masyado po tayong seryoso sa ating pinag-uusapan about the outer planets of the solar system. Okay? So anyway, that's true. 63 Earths will fit into Uranus. Okay? So that's how big the planet is. Now, you will notice that the atmosphere of Uranus has a bluish tinge. Now, let's take a look at the atmosphere of Uranus. Now, the atmosphere of Uranus is composed mostly of hydrogen and helium with traces of methane and ammonia, which is similar to Jupiter and Saturn. Okay? Now, what makes Uranus unique as compared to Jupiter and Saturn? Now, the atmosphere of Uranus contains a higher proportion of methane, and methane absorbs the lower wavelengths of visible light, and that accounts for the bluish tinge in the atmosphere of Uranus. And what makes Uranus unique among the other planets of the solar system is that the axis of Uranus is tilted by 98 degrees. So it seems that the planet is tipped on its side. Para pong nakahiga ang Uranus. Para po siyang boksingero na na-knockdown. Okay, parang nakahiga po ang Uranus. And this is an evidence to prove that in the early history of Uranus, Uranus encountered a massive collision with a protoplanet. This protoplanet knocked down Uranus on its side, and this collision with the protoplanet shifted the rotation of Uranus from counterclockwise to clockwise, which is similar to Venus. So, isn't that fascinating indeed? So, Uranus is really tipped on its side. Okay, very unusual. This is an evidence that in the early history of the planet, Uranus encountered a massive collision. So, that's the reason why the axis of Uranus is tilted by 98 degrees due to this massive collision with the protoplanet. And also, this collision shifted the rotation of Uranus from counterclockwise to clockwise, which is similar to Venus. Okay? Alright, so that's Uranus, and the axis of Uranus is tilted by 98 degrees. The rings of Uranus are oriented vertically. Okay, and that's quite unusual for the planet. Okay, so going back to the atmosphere of Uranus, the atmosphere of Uranus is composed mostly of hydrogen and helium, with traces of methane and ammonia. Now, what's unique about Uranus is that the atmosphere of Uranus contains a higher proportion of methane gas. Okay? And this methane absorbs the longer wavelengths of light, and this causes that bluish coloration of the atmosphere of Uranus. Now, that's fascinating about the atmosphere of Uranus. Okay, let's talk about now the rings of Uranus. Now, the rings of Uranus, they are composed of dust particles and rocky material, which is similar to Jupiter's rings. And what's unique about the rings of Uranus is that the rings of Uranus, they are vertically oriented, as you could see in this picture. Again, because the axis of Uranus is tilted by 98 degrees. So the axis of Uranus is tilted by 98 degrees, so the rings are oriented vertically. And that's quite fascinating about the planet Uranus. The rings are vertically oriented. Okay, so let's go back to our starship and let us now visit the moons of Uranus. Now, these are the 5 largest moons of Uranus. So we have Titania, Umbriel, Miranda, Ariel, and Oberon. Okay? And these are some of the photos of the moons taken by Voyager 2. So we have the following. This is Oberon that is cratered. Okay? And this is Titania, which is the largest moon of Uranus that is also heavily cratered, as you could see in that picture. Then we have, this is Umbriel, again, which is dark and heavily cratered. And this is Ariel, okay, also heavily cratered. And there are signs that Ariel was once geologically active. And lastly, this is Miranda, which is unusual of the 5 moons seen by the Voyager space probe. So there are markings or groove patterns on the surface of Miranda. Okay, so that's fascinating indeed about Uranus. Okay, so I guess that's it for our tour of Uranus. So we can beam back to our starship and let us now travel at warp speed on our way to our next stop in our tour of the outer planets of the solar system. So let us now visit Neptune. So that's the symbol of Neptune. The planet was named after the Roman god of the sea. The Greek counterpart of Neptune is Poseidon. Okay, so let us now activate our sensors and let us gather information about the planet Neptune. Okay, so here is a photo of Neptune taken by the Voyager space probe. And in terms of size, it's obvious that Neptune is much larger than our planet. Okay? And Neptune was discovered in 1846 by J.C. Adams and U.J. Leverrier. Okay? And in terms of the atmosphere of Neptune, Neptune's atmosphere is composed primarily of hydrogen and helium with traces of methane and ammonia. The higher proportion of methane and ammonia accounts for the bluish-green coloration of the atmosphere of Neptune. Now, one odd feature of the atmosphere of Neptune is the so-called the Great Dark Spot. Okay? Now, this Great Dark Spot, as discovered by Voyager, was actually a giant cyclonic disturbance, which is similar to the Great Red Spot of Jupiter. Okay? So that's the Great Dark Spot. And that Great Dark Spot is actually a giant cyclonic disturbance or a giant cyclonic storm. Okay, and Neptune also exhibits high-speed winds or high-velocity winds, but the origin of these high-velocity winds are not yet well understood by astronomers. Okay, so that's the Great Dark Spot of Neptune, which is actually a giant cyclonic disturbance. Okay, and what we have here is the interior of Neptune. So Neptune has a core made of rock and ice, mantle which is made of ammonia, methane ices, and the atmosphere is composed of hydrogen and helium with traces of methane and ammonia. Okay, now Neptune is orbited by 14 moons. And I would like to focus more on these 2 unusual moons of Neptune, which is Triton and Nereid. Now, these 2 moons, Triton and Nereid, they exhibit an unusual orbit. Now, in the case of Triton, Triton is the only satellite or the only moon in the solar system that orbits Neptune in a clockwise direction. Unlike our own moon and the moons in the solar system, our moon orbits the Earth in a counterclockwise direction. Okay? Not Triton. Triton orbits Neptune in a clockwise or backward or retrograde direction. Okay? And that is an evidence that during the early history of Neptune and Triton, probably Triton encountered a massive collision that shifted the direction of its orbit from counterclockwise to clockwise. And the moon Nereid exhibits an unusual eccentric orbit. So medyo mahaba at malaki yung area ng orbit ng Nereid. Okay, unlike the moons in the solar system, Nereid exhibits a highly eccentric orbit. So, Nereid exhibits a long orbital period. Matagal po siyang mag-orbit sa Neptune. Okay, so these are the unusual moons of Neptune. But remember, Neptune is orbited by 14 moons. Now, that's really fascinating about these two moons, Triton and Nereid. Okay, so this is Triton. Triton is the largest moon of Neptune, and Triton is the only moon or satellite in the solar system that orbits Neptune in a clockwise direction. Okay, and Nereid exhibits an unusually eccentric orbit. So that means that the orbital period of Nereid is longer as compared to the other moons. And this is evidence that in the early history of Neptune and the moons, Neptune may have encountered a massive collision with a protoplanet that affected Triton and Nereid. Okay? And that's really fascinating. Now, Neptune has been visited only by one spacecraft, and that's Voyager 2. Now, after its flyby to Neptune, Voyager went out of the solar system, and it is now in interstellar space where no man has gone before. Okay, so that's Voyager 2, which is now out in interstellar space. Okay, so I guess that's it for our visit to Neptune. Alright, so I guess we can beam back to our starship and let us now travel at warp speed on our way to our next stop in our journey to the solar system. So let us now visit Pluto. So that's a symbol of Pluto. Pluto was named after the Roman god of the underworld. The Greek counterpart of Pluto is Hades. Okay? Now, the existence of a ninth planet was predicted by the astronomer Percival Lowell. Okay, Percival Lowell had long predicted the existence of a ninth planet or Planet X. Then in 1930, an amateur astronomer by the name of Clyde Tombaugh discovered that ninth planet at Lowell Observatory in Flagstaff, Arizona. So this is Clyde Tombaugh, and he confirmed the existence of that ninth planet or Planet X in 1930. Okay, so using that observatory in Flagstaff, Arizona, Clyde Tombaugh confirmed the prediction of Percival Lowell. Now let us dig deeper into the mysteries of Pluto. Now for Pluto, there are no visible surface features as seen from Earth. Okay? And in terms of size, Pluto is about 65% of size of the Earth's moon. And with regards to its orbit around the Sun, Pluto exhibits a highly elliptical orbit, coming occasionally closer to the Sun as compared to Neptune. So there are times wherein Pluto is closer to the Sun than Neptune because of its highly elliptical orbit. And also in connection with that, the orbit of Pluto is highly inclined at about 17 degrees as compared to the other planets of the solar system. So that's quite unusual. Okay? And based from spectroscopic analysis of Pluto, it was discovered that Pluto is covered with nitrogen ice and traces of frozen methane and carbon monoxide. And even though the orbit of Pluto is highly elliptical, So that means that there are times that Pluto is closer to the sun than Neptune. Neptune and Pluto will never collide. Now, Pluto is orbited by several moons. The largest moon of Pluto is called Charon. And here is a picture of Pluto with Charon taken by the Hubble Space Telescope. Charon was discovered in 1978, and Charon is about half the size of Pluto itself. And this unusual moon, Charon, is in a tidal lock to Pluto. Okay, so that's quite fascinating indeed. Now, other moons of Pluto other than Charon includes Nix and Hydra. Okay, so that's quite fascinating indeed. Now, astronomers have discovered celestial objects within the orbit of Pluto. And these objects are the so-called trans-Neptunian objects. So this includes Haumea, Makemake, Sedna, Quaoar, and Aries. Now, the discovery of these trans-Neptunian objects enabled astronomers to rethink the status of Pluto as a planet. And in 2005, Mike Brown and his team dropped the bombshell. Why? Because Mike Brown and his team discovered an object further out than the orbit of Pluto that was probably the same size or even larger than Pluto. And they designated this as UB313, which was later renamed as Aries. So they doubted now the status of Pluto as a planet. Now, what makes an object a planet anyway? Now, in order for an object to be a planet, it needs to meet these three requirements. Okay, the first one is a planet needs to be in orbit around the sun. And Pluto satisfies that requirement. Pluto orbits around the sun. Okay? Now, the second requirement for an object to be considered as a planet is that it needs to have enough gravity to pull itself into a spherical shape. Now, Pluto is spherical in shape, so it satisfies that requirement. Now, the third requirement in order for an object to be considered as a planet is that the object needs to have cleared the neighborhood of its orbit. Now, because of the discovery of these trans-Neptunian objects, Pluto failed to satisfy that third requirement. So that was the rule breaker. Okay? And according to this, Pluto cannot be considered as a major planet. Many astronomers now demoted Pluto into a dwarf planet status. Now, what does cleared the neighborhood of its orbit mean? Now, that statement simply means that a planet has to be the dominant gravitational body in its orbit around the sun, and there are no other bodies of comparable size other than its natural satellites. Now, since the discovery of Aries by Mike Brown, which is bigger than Pluto, plus the other trans-Neptunian objects like Makemake, Haumea, Pluto is not the dominant object in its orbit around the sun. And that's quite obvious. So therefore, most astronomers believed that Pluto cannot be classified as a major planet. Okay, so Pluto was demoted into a dwarf planet status. Now, Pluto plus the other trans-Neptunian objects are located in this region of our solar system known as the Kuiper Belt. The Kuiper Belt is that region beyond the orbit of Neptune at the edge of our solar system. So Pluto, Makemake, Haumea, Aries, they are located in this region called the Kuiper Belt. The Kuiper belt is like the asteroid belt, but the Kuiper belt is at the edge of our solar system. Ceres is an asteroid in the asteroid belt, and Ceres is considered also as a dwarf planet. Pluto is in the Kuiper belt, and Pluto was demoted into a dwarf planet status. Now, even though Pluto is considered as a dwarf planet and is no longer officially called a planet, still Pluto is a fascinating target for study. And NASA had sent their New Horizons spacecraft to visit Pluto. New Horizons had reached Pluto last July of 2015. So isn't that fascinating? So here is the New Horizons. The New Horizons is the fastest man-made object so far. And it took 9 years for the New Horizons to reach Pluto. The New Horizons reached Pluto in 2015. And these are just some of the magnificent photos taken by the New Horizons of Pluto. Okay, so that's really fascinating indeed. Now, there are other members of the solar system that we need to mention, such as comets. Now, what is a comet anyway? Now, a comet is a small body in the solar system that orbits the sun just like the planets. But a comet has a head or a coma and a long, magnificent tail. And comets are basically made up of ice and dust. A comet is basically a ball of ice and dust that looks like a star with a tail. So many astronomers would consider comets as dirty snowballs. Now, just recently, we have observed a comet about 2 months ago, and this comet was named Comet Neowise. So that's really fascinating. So that's what a comet is. A comet basically is a small body made up of ice and dust, and it has a head called a coma and a long tail. And that tail of the comet is made up of ionized gas. And the tail interacts with the sun. Comet tails are produced through interaction with either the solar wind or photons of sunlight. And that means that the tail always points away from the direction of the sun. Okay, as you could see in this animated illustration. So the tail interacts with the solar wind or photons of sunlight. So that means that the tail always points away from the direction of the sun. So that's really fascinating indeed about the tail of a comet. So the tail of a comet is composed of ionized gas, and the tail interacts with the solar wind. And that's the reason why the tail of the comet always faces in the direction away from the sun. Now, let's take a look at this animated illustration. Now, as the comet approaches the sun at its perihelion, the coma interacts with the solar wind, producing that long, magnificent tail. Now, we know that the tail is composed of ionized gas. So that tail interacts with the solar wind, and that's the reason why the tail always faces in the direction away from the sun. And as the comet moves farther from the sun, the tail gradually disappears, and the comet now looks like 30 snowballs in space. Now that's very interesting about comets. So let's take a look again at this animated illustration. So as the comet approaches the sun, the comet interacts with the solar wind, producing that long, magnificent tail. And as the comet moves farther from the sun, the tail gradually disappears and the comet looks like dirty snowballs in space. And we know that the comet's tail is composed of ionized gas, And this is the reason why the tail always faces in the direction away from the sun. And the most famous comet of them all was the comet that was named after Edmund Halley, the so-called Halley's Comet. Now, you might wonder about the origin of comets. Now, comets, they originate in that region of the solar system known as the Oort cloud. The Oort cloud is at the edge of our solar system. Okay, so that's interesting indeed. Now, let's go back to our starship. Let's beam back to our starship, and let us now travel at warp speed on our way to the center of the solar system, which is our sun. Now, in terms of size, our sun is about 865,000 miles in diameter. And our sun is actually a star. Our sun is a medium-sized star or a class G star. And the sun is made up of gases such as hydrogen and helium. And what happens inside the sun, hydrogen atoms fuse or combine to form helium. And that's what we call nuclear fusion. And nuclear fusion releases a tremendous amount of energy. So the sun is actually a nuclear fusion reactor that gives us light, heat, and solar energy. Now, our sun exhibits the following layers. Now, the surface of the sun is called the photosphere. Now, the photosphere appears granulated. Again, this is due to boiling gases. Then, above the photosphere is the chromosphere. The chromosphere appears as a halo above the photosphere. Then, above the photosphere is the solar corona. The solar corona is visible during a total solar eclipse. So everybody, kindly take a look at this illustration that represents the layers of our sun. So the surface of the sun is the photosphere. The photosphere appears granulated, again due to boiling gases. Then above the photosphere is the chromosphere. The chromosphere appears as a halo above the photosphere. And above the chromosphere is the solar corona, which is visible during a total solar eclipse. So we have here the surface of the sun or the photosphere. Now the photosphere appears granulated because of these boiling gases. Okay, then above the photosphere is the chromosphere. And above the chromosphere is the solar corona. Then with regards to the internal structure of the sun, you have the following layers. So you have the inner core. The inner core is that layer of the sun wherein nuclear fusion occurs. Then the energy that is released through nuclear fusion is transferred to the radiative zone, and in the convection zone, then up to the photosphere. So that's the internal structure of our sun. So again, we have the internal structure of the sun. So at the center of the sun, we have the core, and nuclear fusion occurs inside the core. Then the energy that is released at the core is transferred to the radiation zone, and in the convection zone, then up to the photosphere. So that's the internal structure of our sun. Okay, and we have here an animation of a total solar eclipse. And we can see there the solar corona. The solar corona is visible only during a total solar eclipse. So isn't that fascinating indeed? So that's the solar corona, which is visible during a total solar eclipse. Now, as a result of nuclear fusion, our sun produces solar wind. Now, by definition, the solar wind is a constant flow of high-energy particles from the sun, and their velocity ranges between 300 to 800 kilometers per second. Now, the presence of these solar winds would indicate that our sun is actually losing mass. Remember the equation of Albert Einstein, E equals mc squared? So mass is converted into energy, and that's what happens inside the sun. The mass of the sun is converted into a tremendous amount of energy through nuclear fusion. So the presence of the solar winds would indicate that our sun is actually losing mass. The mass of the sun is converted into a tremendous amount of energy through nuclear fusion. So that's the solar winds, which is a constant flow of high energy particles from the sun. Now let's talk about sunspots. Now, sunspots were first discovered by Galileo Galilei, and as seen through the telescope, sunspots are areas that appear dark on the surface of the sun. Now, they appear dark because sunspots have a lower temperature as compared to the other parts of the sun's photosphere. Now, even though they are cooler than the other parts of the sun, sunspots are still very hot with temperatures of around 6,500 degrees Fahrenheit. And sunspots are actually magnetic storms. Sunspots are associated with the sun's magnetic activity. Now, sunspots are really magnificent to observe, especially if your telescope is equipped with a solar filter. And sunspots, they follow an 11-year cycle. So these structures on the photosphere, they indicate magnetic activity of the sun. Sunspots are actually magnetic storms, and sunspots are even bigger than the Earth. So everybody take a look at this picture of a sunspot and compare that with the size of the Earth. So isn't that fascinating indeed? Okay, sunspots are intense magnetic storms on the sun's photosphere. Now, if you will look closely at this photo of a sunspot, you can see magnetic lines of force etched in the photosphere. Okay, look at these two sunspots and you will see the magnetic lines of force traced in the sun's photosphere. So that indicates magnetic activity. Sunspots are magnetic storms and they indicate the magnetic activity of the sun. Now, associated with the sun's magnetic activity are solar prominences. Now, a prominence is a large, bright feature that extends outward from the sun's surface, often in a loop shape or loop appearance. And prominences are anchored to the sun's surface in the photosphere, and they can extend outwards into the sun's corona, as you could see in this photo of the sun, with those prominences extending outwards into the solar corona. Okay, here is an animation of that magnificent looping of solar material following the sun's magnetic lines of force. Fascinating, isn't it? So these magnificent features of the sun, they are associated with the sun's magnetic activity. Okay, so those are solar prominences. Really fascinating indeed. And these solar prominences, they are even bigger than our planet. Okay, all right, so those are solar prominences. Alright, so let's talk about now solar flares. Now, a solar flare is a sudden brightening observed over the sun's surface or solar limb. Now, this sudden brightening is interpreted as a sudden release of energy. So, para pong may pumutok sa surface ng sun. And a solar flare ejects high energy particles like protons, electrons, ions through the corona of the sun into space. So radiation po ito. Solar flare emits radiation. And these high energy particles, they typically reach the earth a day or two after the solar flare event. Okay? So this is a sudden brightening of the sun's surface. And this sudden brightening is interpreted as a sudden release of energy. So talaga pong parang may pumutok sa surface ng sun, releasing high energy particles like ions, electrons, protons, or radiation. Okay? And a solar flare is even bigger than the Earth. Look at this photo of a solar flare. Compare that with the size of the Earth. Okay, so that's really magnificent. A solar flare emitting high energy particles. And this is quite dangerous. It will affect life on Earth. Okay, so what are now the effects of solar flares? Now, the X-rays and UV radiation emitted by solar flares can affect the Earth's ionosphere, and it may even affect long-range radio communications. Okay, direct radio emissions at decimetric wavelengths may disturb operations of radars and other devices operating at these frequencies. Okay? So, these high energy particles emitted by solar flare will affect the ionosphere, and it may disrupt radio communications. And because of these solar activities, and it may affect the ionosphere, we have the formation of the so-called auroras. Okay, we have the aurora borealis and aurora australis. Now, these auroras, they indicate solar activity. So, well, I guess that's about it for our guided tour of the outer planets of the solar system. I hope you have learned a lot about the outer planets through this episode. At sana po ay nakatulong po kami sa mga estudyante na nakikinig po ngayong gabing ito sa inyong pag-aaral ng siyensya at astronomiya. Binabati ko po ang mga officers and crew ng Vedan Society of Young Astronomers. Binabati ko din po ang Grade 11 STEM of San Beda University na aking mga estudyante. At pa-shoutout po sa Chairman of the Board of the Philippine Astronomical Society na si Engineer Camilo Dacanay na nakikinig po ngayong gabing ito. At marami pong salamat sa inyo, my dear netizens, sa walang sawang panonood po ng ating programang Space, The Final Frontier. Now, we won't be airing our 4th episode this coming Saturday, January 30, to give way for our activity entitled Rock the Stars 2021. Ito po ay parang Battle of the Bands na may konting astronomiya. So, I would like to invite the public, kayo po, dear netizens out there, to watch Rock the Stars 2021 this coming Saturday, January 30. And also, please watch our activity on January 29. This will be a virtual telescope viewing entitled Starry Night. This is our way of celebrating the Pista ng Santo Niño here at San Beda University. So don't forget, my dear netizens, on January 29, we will be having Starry Night. This is a virtual telescope viewing. We will start at 7 o'clock in the evening. And on Saturday, January 30, we will have the Battle of the Bands entitled Rock the Stars 2021. So thank you for watching. This is your Commander, June Cajigal, saying, live long and prosper. And I will see you on February 6 for our next episode of Space, the Final Frontier. So stay safe, everybody, and good night. I will see you on January 29 for Starry Night, January 30 for Rock the Stars, and for the 4th episode of Space, the Final Frontier on February 6. Stay safe and good night. Of the solar system. So, as the title indicates, ulit. 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 System. Okay, so let us now proceed with this
Oh no!
Now, to further help you understand the formation of the solar system, let's watch this fascinating video about how our Okay, so before we beam up was similar to Venus. Uranus was not spared from that
Oh no!
ulit, massive collision with a protoplanet. So Venus oh boy. Okay, lapit na. Isa na lang. Isang take na lang. 63 Earths will fit into Uranus.
Oh no!
Or that's a joke. Uranus. So 63 Earths will fit into Uranus, and 64 if you relax. Okay. Oh, mali. Ulitin natin. Take 2. In fact, 63 Earths can fit into Uranus. That's not the Uranus. Oh, hindi mo kinapakinggan yun ah. Okay, so again, ulitin natin. Ayan. So, 63 Earths will fit into Uranus and 64 if you relax. Okay? So, hindi po... Ay, mali. Mali. Dapat ito. Hindi, iba na lang yung ano. Okay, ulit. The Earths will fit into Uranus. What? Ano? 60... Ha? Ang pangit pakinggan nun ah. 63 Earths will fit into Uranus? What? Okay, ulit. Isa na lang. Now, one reason why Uranus exhibits a retrograde rotation on its axis is because that during the early history of Uranus
Oh no!
thank you.
There she is. NASA's Voyager 1. Launched in 1977.
But that's just very small potatoes compared to what the Earth is involved with and knows about.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
It's one small step for man, one science leap for mankind.
Resilience rises. Not even gravity contains humanity when we explore as one for all.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone.